This is the Murray-Darling Basin, Australia's largest river system. In the 1970s, European carp escaped from ponds and took it over. In some stretches, 90% of all fish are carp. People tried almost everything. They set nets and traps, spent millions fighting them. But after every flood, there were even more. And then something changed. On one island near these shores, carp disappeared. Down to the last fish. It seemed the answer had been found. But what worked on one small island was an entirely different challenge on Australia's main river. For decades, carp was a manageable problem. Numbers stayed within bounds. Spread was limited to individual ponds, canals, and river stretches. The situation changed, not because the carp changed, but because the river changed. During the great floods of the 1960s and 1970s, fish escaped from ponds and spread across the entire Murray-Darling Basin. This is a two-river system draining roughly 14% of the entire continent, a territory larger than Texas and California combined. It produces approximately a third of all of Australia's food. And carp claimed it for itself. Today, in some parts of the basin, carp make up more than 90% of all fish biomass. 9 kilograms out of every 10 of living silver in Australia's largest river is a single introduced species. You don't need graphs to see this. During fish surveys in the Macquarie Marshes, CSIRO ecologist Tom Rayner would lift adult carp out of the water with both hands. Heavy, muscular fish the color of bronze, one of thousands pulled in the same haul. In some locations, the density exceeds 350 kilograms per hectare. Imagine a small pond where the fish outweigh an adult horse. Americans know the feeling. Along the Mississippi and on the approaches to the Great Lakes, the country has spent years at war with Asian carp, fish of the same family, the same relentless appetite. Australia simply lost that war half a century earlier. The problem isn't that carp eat anything, it's how they feed. They filter mud and gravel through their mouths, searching for larvae and plant debris, and expel it back as a cloudy jet. One fish does this for hours. Millions of fish do it without pause. The water turns turbid. Light stops reaching the bottom. Aquatic plants die without sun. With the plants gone, cover for native fish fry disappears. Banks that roots once held collapse. Where there was once a clear pool, brown suspension now blooms with blue-green algae. The Australian government estimates direct losses conservatively, around $200 million per year. Blocked irrigation pumps, eroded banks, lost native commercial and sport fish, and then, in 2022, the water came again. The massive floods that year inundated floodplains across the southeast, perfect conditions for carp spawning. The fish rushed onto the flats, laid eggs in warm shallows, and the population exploded to a historic peak. 375 million individuals. What people had spent half a century trying to hold back doubled in a single spring. The question this raised no longer sounded like an ecological debate. It sounded like a siege. How do you stop a fish that outnumbers everything else alive in the river? The first answer looked elegant. Let nature do it. The Murray-Darling Basin is home to one of Australia's oldest predators, the Murray cod. The name is misleading. This is not a cod, but a freshwater giant from a lineage older than most of the rivers it swims in. Murray cod grows to over 1 meter in length and lives more than half a century. Individual fish older than the people who hunt them. Within its river, it is the apex predator at the top of the food chain. The logic was simple and tempting. 375 million new units of live prey had appeared in the river. A predator already lived there capable of swallowing fish the size of its own head. Give the predator more to eat, and it would do the rest. The idea was tested seriously. Researchers from the Invasive Animals Cooperative Research Centre together with the University of Queensland ran a series of experiments in laboratory aquariums, in enclosed ponds, and in the open river. They watched whether native predators, Murray cod and golden perch, actually ate carp, how much, what size, and under what conditions. One study found carp in 35% of examined Murray cod stomachs. Predation was not occasional, it was routine. 1 in 3 cod was eating carp. The mechanism seemed to work. More predators were all that was needed. Then the scientists looked more carefully and saw what the 35% figure had hidden. Back in 2006, Ecologist Brendan Ebner dissected the stomach contents of Murray cod and golden perch collected by anglers to understand which of them was the true hunter. The difference was striking. In Murray cod's diet, other fish made up over 90% by weight, meaning cod lives almost entirely by hunting fish. Golden perch barely registered by comparison. There was one genuine apex predator. On paper, the ideal weapon against carp. But field researchers who went out on the river afterward found a trap hidden in the geography. They caught fish across the entire channel by electrofishing, nets, and traps. They set them in lagoons, side channels, and the main current, and they found that carp and predator barely crossed paths where it mattered. Small carp raised their offspring in warm, shallow bays that large cod don't enter. And by the time carp grew large enough to reach the deep water of the main channel where predators hold station, they were already too big to swallow. The researchers stated their conclusion plainly. Native predators are unlikely to significantly affect carp numbers. 35% of stomachs containing carp meant not victory, only that cod eat carp when carp happen to be there. There was a second problem, quieter than the first. To make predators eat more carp, you need more predators, which means stocking rivers with cod and golden perch. But a hungry predator doesn't discriminate. Build up an army of cod to go after carp, and you risk them eating the very native fingerlings you're trying to save. The cure could turn out to be another disease. The river had grown carp a perfect nursery that predators couldn't enter. Nature was not going to fix what humans had done. A different weapon was needed, and it already existed, half a world away. Go back south, across Bass Strait, to those two Tasmanian lakes. Carp were discovered in Lakes Crescent and Sorell in 1995. Someone, most likely, released a few fish illegally as bait for trout or simply something to catch into two large lakes with internationally significant wetlands, home to an endemic fish, the golden galaxias, which exists nowhere else on Earth. Inland Fisheries Service did something nobody had done at that scale. It decided not to contain the carp, but to eliminate it entirely. They started with the smaller lake, Crescent. The tactics were methodically lethal: blanket gill nets, electrofishing, traps, barriers across spawning routes. The last carp in Crescent was caught in 2007. 12 years of work, 7,797 fish, and the lake was declared carp-free. That left the larger Lake Sorell, and there the real hunt began. The team used a technique that sounds like betrayal: Judas carp. A dozen male carp were caught, fitted with radio transmitters implanted under the skin, and released back into the water. Carp are schooling fish, especially during spawning when individuals gather together in warm shallows. A tagged male, following instinct, swam directly to other carp, and the hunters followed the signal from his transmitter and netted the entire school he had just led them to. Years of this hunting did something strange to the fish itself. Service Officer Chris Wisniewski explained it simply. The team had spent years removing the largest and strongest individuals, skimming, in his words, the cream from each generation. What remained, as he put it, were the dregs, mutants, and runts. More than half the surviving males turned out to be sterile, due to diseased gonads that made reproduction impossible. Annual juvenile surveys in Lake Sorell recorded no new generation of carp from 2013 onward, despite the springs of 2016 and 2021 providing ideal spawning conditions. The last fertile male was caught in the 2018 to 2019 season. And then came that 2022 to 2023 season, and one single female in the net with which this story began. In June 2023, after 28 years and 41,000 carp removed from Sorell, the service announced, "Carp in Tasmania are functionally eradicated, meaning if a few fish remain somewhere, they are no longer capable of reproducing." Program leader Jonah Yick took the story to an international fisheries conference in Auckland, the most successful carp eradication in world history. 28 years of one strategy, seen through to the end. And life returned to the lakes. The golden galaxias, a fish that exists nowhere else in the world, survived. Lake Crescent, closed for years to enable the fight, was reopened for fishing. Lake Sorell, once one of Tasmania's most popular trout fisheries, began drawing back the anglers who once numbered in the thousands each year. The place carp had nearly taken was returned to the people and the native fish, but it worked across 2 lakes totaling roughly 76 square kilometers, an enclosed system, counted water. The Murray-Darling Basin is 1,000 times larger. There are no banks to grasp the whole system by. Judas Carp won't lead you to the last school when there are millions of schools. For a continent, what was needed was a weapon that acts on its own, everywhere, simultaneously. In 1998, domesticated carp in Israel suddenly began dying. The cause was a new virus, cyprinid herpes virus 3, or carp herpes. It spread across the world with startling speed. Japan, Indonesia, North America. Mortality among infected carp reached 70 to nearly 100% in some cases. The virus had one property that made Australian researchers catch their breath. It killed carp and almost nothing else. Goldfish and other fish, as far as was known, didn't become sick from it. Nature had done precisely what Murray cod couldn't, produced a killer tuned to exactly one species. CSIRO researchers brought the virus to a maximum security laboratory in Geelong, Victoria, the Australian Centre for Disease Preparedness, one of the most restricted biological facilities in the world. Behind its walls, the virus could not escape by any route. For years, they infected Australian carp with controlled doses and watched what happened. This was work of genuinely unprecedented novelty. Nobody had previously attempted to legally release a virus to control a vertebrate animal in a continent's wild environment. The project's lead scientist, virologist Ken McCall, summed up the result briefly. The virus genuinely kills Australian carp, and kills them quickly. An infected fish swims for a few days with no sign of illness. Then, within a day or two, it is over. The weapon seemed found, precise, self-spreading, ready to sweep the entire basin. In 2016, the Australian government invested $15 million in the National Carp Control Plan, 11 research institutions, more than 40 scientists. One question: can this virus be safely released into Australia's rivers? 7 years of work. And in November 2022, the plan was finally made public. It did not say yes. It did not say no. Here's what the years of research showed in numbers. The virus works on Australian carp. Mortality among infected fish reaches around 80%. The laboratory result was unambiguous. But when scientists calculated what would happen to the population at the scale of the entire basin, the picture became more restrained. The released plan estimated that the virus could reduce carp numbers by roughly 40 to 60%. Not eliminate, reduce. The most likely scenario looked like this. A first major outbreak kills the majority of fish, after which seasonal waves of disease roll through each year, keeping the population suppressed. 40 to 60% of 375 million is tens, possibly hundreds, of millions of dead carp. And here a question appeared that stopped the plan cold. What to do with the bodies? If the virus works as intended, it will simultaneously kill millions of fish in key stretches of the river. Millions of bodies decomposing in the water together. Decomposition strips oxygen from the water. And without oxygen, what the virus was meant to save dies too. Native fish, Murray cod themselves, water birds, everything alive in the river that has nothing to do with carp. Saving the river could suffocate it faster than carp was doing. And this is not the deepest crack in the plan. In 2020, a research group led by Catherine Minturn from the University of Exeter in England built a computer model. They wanted to test not whether the virus kills carp, but what happens afterward. The model accounted for 2 things easy to forget in the excitement of kills quickly. First, carp reproduce explosively, 1 female, 1 million eggs. Second, within the global carp population, individuals already exist that are resistant to this herpes virus. They put a brutal question to the model. How long would a population need to recover, even if 95% of the fish were killed? The answer was discouraging. The very traits that made carp such a successful invader, staggering fecundity and rapid transmission of resistance to offspring, allow an infected population to recover rapidly, and to recover from precisely those individuals the virus cannot kill. In other words, the first strike would be devastating, but the survivors would be exactly those the virus cannot touch, and they would repopulate the river, already immune to the only weapon held against them. Minturn called the plan dead in the water. One of the architects of the viral strategy himself had pointed to this trap. In a 2016 paper, Ken McCall and colleagues suggested that as carp begin developing resistance, New and progressively more aggressive virus strains would have to be periodically released, simply to keep pace with the fish's evolution. An arms race without a finish line. You don't kill the enemy once and for all, you commit to holding a new disease against it every decade, indefinitely. The virus's proponents disagree. They argue that even temporary suppression for a decade would give native fish a chance to recover, and the virus can be combined with other methods. The debate continues. So when state governments gathered to decide the plan's fate, they said neither yes nor no. They commissioned more research. The decision was deferred for years. The virus has not been released into any Australian river. Animal welfare advocates add their own voice. Animal protection organizations insist fish feel pain, and even if carp must be killed, it should be as painlessly as possible, and a slow death from herpes virus doesn't meet that definition. Here then is where things stand. The most precise biological weapon ever prepared against carp sits in a vial in Geelong. It kills quickly, it strikes almost only at its target, and they are afraid to release it because nobody can guarantee that after the strike, carp won't return stronger and the river won't suffocate from its own salvation. 375 million fish wait in the turbid water, and the people who hold the decision in their hands cannot bring themselves to press. The virus is proven and ready, but locked in a laboratory in Geelong. State governments have spent years unwilling either to release it or to abandon it. Instead of a decision, another phase of research. In the meantime, 3 options remain for people, and each is bad in its own way. Release the virus and receive millions of tons of dead fish in the water, suffocated banks, and the risk that carp returns already resistant to it. Do nothing and leave the continent's largest river in a state where 9 out of 10 fish are alien. Or the third path, being quietly tested right now, breed carp that produce only males, and for years introduce them into the river until females disappear entirely. No carcasses, but no guarantee of success before it's too late. While the meetings continue, carp don't wait. Every new flood, and there are more of them now, is another population explosion for the fish. 375 million was the peak after 2022. The next big water will make that number look old. Australia already knows carp can be beaten. Tasmania proved it. It simply hasn't yet decided whether it's willing to pay the price, and with each year of delay, that price rises.